Our last topic, and much simpler than projectile problems, is circular motion. Circular motion is another type of two-dimensional motion. As this object moves around the circle, it moves vertically. It was here, now it's higher, and then it'll be higher, and then it'll get lower, and then much lower, and then it'll start getting higher again. So it's moving vertically, and it's moving horizontally at the same time. So it's another brand of two-dimensional motion. How does the Earth remain in orbit around the Sun? Well, there is a force. What is it? Gravitational force, right? There's a gravitational force, the Sun pulling on the Earth. So the force would be directed this way. What force holds the Earth in orbit? Well, sorry, I just answered that. It's the gravitational force. And the direction of this force is towards the Sun. So the Earth has velocity in this direction, tangent to the circle. And so this velocity is actually called tangential, T-A-N-G-E-N-T-I-A-L. Tangential velocity. All of the time, an object that's moving in a circle has velocity that's tangent to the circle. And that would be perpendicular to a radius. It's over here. It's going to be moving this way, tangent to the circle. So if something's moving in a circle, its velocity at any instant is tangent to that circle and perpendicular to a radius. The direction of the force that's making that happen is towards the center of that circle. The force and acceleration all of the time for something that's moving in a circle is towards the center of that circle. We call a center-seeking force centripetal. And that means center-seeking. Acceleration is called centripetal acceleration. So this would be a centripetal force. And we would call a centripetal force, we would write the symbol FC, and we would write the symbol for centripetal acceleration, AC. Now it's important to realize these aren't new forces. They're old forces acting in a new way. Gravitational force is not a new type of force. We've talked about gravitational force before. Other forces can cause things to travel in circles. Tension, if you hold a string that has an object at the end and you swing it around in a circle, the tension in that string would be providing the centripetal force. Normal forces, friction, all of these can provide circular forces or centripetal forces. So let's do a problem. Oh, the equation's important. Centripetal acceleration is equal to the velocity squared divided by the radius of your circle. Well, remember, Newton's second law says F equals ma. So centripetal force is just mass times centripetal acceleration. So it's mv squared over r. R is in meters, velocity will be in meters per second, and mass will be in kilograms. Let's try this. A runner is running around a circular track, radius 50 meters. So there's our r, there's our mass. With a speed of 5 meters per second, there's our velocity. What force is allowing him to run in a circle? Find the magnitude of this force. So what I'm asking, what is the force that's keeping that runner running in a circle? Well, think about what's happening to his feet. It's the friction with the road that is acting on him. He's pushing outward and the frictional force is pushing inward. Think about a car. It might be a little bit easier to see. If you're on a circular track in a car and you're right here and you're moving this way, and your car goes around this track and you get back to here. Suppose you're on a magic track and suddenly the track is covered with ice. Well, what's going to happen? When your car, instead of continuing to go in a circle, will go straight because you need friction on the tires to push the car towards the center of that circle. So in this case, it's a frictional force that's causing a centripetal force. So let's calculate it. Centripetal force is mv squared over r. The mass was 50 kilograms. Velocity is 5 meters per second. v squared, and the radius is 50 meters. Well, I don't even have to get my calculator out because 50 and 50 cancel to equal 1, and 5 squared is 25. So the answer is 25 newtons. If it had asked for acceleration, we would have just done v squared over r. Centripetal force is m v squared over r. Centripetal acceleration is just the v squared over r part. So what happens, we kind of alluded to this a minute ago when we were talking about what happens if the magic track turns to ice. If an object is moving in a circle and whatever force is causing it to move in a circle stops. So like if we're going to do a lab where we'll have a little cylinder and there's a weight hanging down, there'll be a string going through, and we're going to swing this object around in a circle. So the tension in this string will be keeping this object moving. Well, what happens if the string breaks, if there's no longer a force acting centripetally on that mass? Well, it continues to move in whatever direction it was moving. And remember, if an object's going in a circle, its velocity at any given instant is tangent to that circle, perpendicular to a radius. And so if the string broke over here, the object would move off in this direction. If the string broke here, and the object is moving like this, it would continue to move like that. Misconceptions are that it would continue to swirl, but with bigger, I guess a spiral out, but that's not how it works. It would just, remember Newton's first law says, if there's no net force acting, the motion's constant. So once this force stops acting, there's no more acceleration, so it'll move in a straight line. And that's the end of circular motion. Thank you so much.